Up to this point, we've mostly been looking at quadratic equations in one variable, but now we're going to turn our attention to quadratic functions in two variables. So there are three main forms of quadratics: standard form, ax squared plus bx plus c; vertex form, a times x minus h squared plus k; and root form, a times x minus r1 times x minus r2. So, standard form, y equals ax squared plus bx plus c. A represents the tightness of the graph. So it represents how small or wide it's going to be. B represents the starting slope. So that value of what the slope is going to be when x equals 0. And C represents the point, the y-intercept right there. These are the a, b, and c for the quadratic formula, which, if you've forgotten, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Standard form is useful for finding y-intercept, for using the quadratic formula, but it's bad for finding the roots, vertex, and range. You can do all of those things, but this is the strength of standard form, to find the y-intercept or use the quadratic formula. Vertex form, we see a times x minus h squared plus k. A represents the same tightness that we talked about. H comma k represents the vertex. Note that there's a negative there in here. So if we see x plus 5 squared plus 3, the vertex is negative 5 comma positive 3. So the sign will always be opposite there. It's easy for finding the vertex, and because the range is connected to the y-coordinate of the vertex, when we say, okay, this one is at negative 5 comma 3, we can say that, okay, now our range has to be y is greater than or equal to that 3. It's bad for finding the roots, because there's more calculation that you have to do, or the y-intercept, because plugging in 0 here, there's still some calculation to do. Root form still has the tightness, and then the roots, where it crosses the axes. So the x-axis, the x-intercepts are the roots, or the solutions, or the zeros, and the root form is good for finding the roots. But realize not all quadratics have roots. If I gave you this equation, or this parabola, it doesn't have any roots, so it doesn't have a root form. Root form is bad for finding the y-intercept, bad for finding the vertex, and bad for finding the range. So the way that we get between these, to get to standard form, we simplify. To get from standard form to a root form, we factor. You see that it looks factored. And here we have a perfect square trinomial, so we have to complete the square to get it to vertex form. Without going through key information, it's hard to go between vertex form and root form without going through standard form first. So let's convert to standard form. That means that we need to simplify. So we'll distribute 3 times x squared plus 10x minus 12x minus 120 gives us 3x squared plus, minus 2x minus 120. And now distributing, y equals 3x squared minus 6x minus 360. Now it's in standard form. Here, we have to simplify this part. Order of operations says do that first. You cannot distribute the negative 2 first. X squared plus 6x plus 9. Now we distribute the negative 2. Negative 2x squared minus 12x minus 18 minus 7. Y equals negative 2x squared minus 12x minus 25. And that's our standard form. Here's vertex form. To convert to vertex form, that's completing the square. So we'll take that 10, cut it in half, and square it to get 25. So we'll add a 25 and subtract a 25. So we add 25, subtract 25, and we still have the plus 3. Those will be combined, and these become a perfect square. X plus 5 squared minus 22. That's vertex form. Here, we want to divide out the negative 4, giving x squared minus 6x, and we still have minus 80. Now, looking at the negative 6, we'll take negative 6. Let me put that in red so you see that it's connected to the second problem. It becomes negative 3. Squaring that becomes 9. So we'll add 9 inside the parentheses. X squared minus 6x plus 9 minus 9 minus 80. Distributing the negative 4 to the negative 9 gives us a positive 36 minus 80. What's left has x squared minus 6x plus 9 plus 36 minus 80. And now y equals negative 4, x minus 3 squared. That's from here. And then positive 36 minus 80 is minus 44. Those are in vertex form. To convert into root form, that's factor. So we can factor out a 2. Say this is x squared minus 8x minus 20. And the factors that multiply to negative 20 are 1 and 20, 2 and 10. That'll work with a positive 2 and a negative 10. So y equals 2, x plus 2, x minus 10. Here, we're going to have to do 15 times negative 8, which gives us negative 120. So the factors of negative 120, 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24. 5 and 24 work. So positive 5, negative 24 will allow us to write this as 15x squared plus 5x minus 24x minus 8. The first two have a common factor of 5x. So 3x plus 1 minus 8 times 3x plus 1. So the factored form is 3x plus 1 times 5x minus 8. So that's root form. So we've already talked about how to find the various pieces. What's colored in each of these is what's specific for that form. So for standard form, the y-intercept is just c. And the axis of symmetry you can calculate with negative b over 2a. The rest you find normally. So x-intercepts, you normally set y equal to 0 and solve. You could use quadratic formula. Vertex, you substitute the axis of symmetry that you found here for x. The domain is going to be all real numbers, unless it's a word problem. And the range, you check a to pick y is greater than or equal to k, or y is less than or equal to k. And when I say k, I mean the y-coordinate of the vertex. For root form, we do our normal setting x equal to 0 for y-intercept. We normally substitute in the axis of symmetry for x for the vertex, all real numbers, check a. For the roots, you're given the roots. It's r1 and r2. For the axis of symmetry, it's averaging r1 and r2. For the vertex form, finding the intercepts is normal, finding the domain and range is normal. The axis of symmetry you're given as h, and the vertex is just h comma k. So, putting it all together. Here, these are 3 different versions of the same exact function. If we graph this, you'll see here. This is the parabola. The green point is the y-intercept of 0, 3, which you also see here in the standard form of the equation. The roots are 1, 0 and 3, 0, which you also see here and here. The axis of symmetry is that 2, and the vertex is that positive 2 and negative 1. The domain is all real numbers, unless it's restricted by a word problem. And the range, we start from -1 and go up. So that's y is greater than or equal to -1. You can convert between these, from either of these to the standard form by simplifying. You can complete the square to go to vertex form, or you can factor to go to root form. Thank you.